Hi everyone, today I will be discussing the several important topics in computer architecture and processing systems. These topics include how the CPU works, the evolution of CPU, processing power from part 1 to part 4, an overview of the GPU, and finally, the operations and programming of SAP 1. Understanding this topic is essential because the CPU and GPU from the backbone of modern computing, while SAP1 help us understand how processors work at a fundamental level. By the end of this video, you will see how early computing concepts evolved into the powerful system we use today. So, part 1 is how the CPU works. Let us begin with how a CPU works. The Central Processing Unit or CPU is often called the brain of the computer. Its main function is to execute instructions and process data. A CPU performs its tasks using what we call the fetch, decode, execute cycle. Fetch. First, the CPU fetches an instruction from the main memory or the RAM. This instruction is stored at a specific memory address. The program counter keeps track of which instruction comes next. Decode. Next, the instruction is decoded by the control unit. Here, the CPU determines what operation needs to be performed, such as addition, subtraction, or data transferred. Execute. Finally, the instruction is executed. This is usually done by the arithmetic logic unit or ALU, which performs arithmetic and logical operations. Example. For example, if the instructions is add A, B, the CPU fetches these instructions, decodes it as an addition operation, and execute it by adding the values stored in register A and B. This simple cycle repeats billions of times per second in modern CPUs, which explains why computers can perform complex tasks very quickly. Part 2. Evolution of CPU Processing Power. So, also we have part 2.1, the evolution of CPU processing power. In the early days of computing, CPUs were very simple. They were built using basic electronic components such as vacuum tubes and later transistors. These early CPUs had very few instructions, limited memory, no multitasking capability. Each instruction had to be processed one at a time. Key concept and the main focus of early CPUs was correct execution, not speed. Example, early computers like the ENIAC could only perform a few thousand operations per second, compared to billions today. Despite their limitations, these early designs laid the foundation for registers, instruction sets, control units, These components concepts still exist in modern CPUs. Part 2.2: The evolution of CPU processing power. The next major milestone was the rise of the X8 times 86 architecture. Intel introduced the X times 86 family starting with the 8086 processor. This architecture became extremely power popular because it was backward compatible. What does backward compatibility mean? It means newer CPUs could still run older programs. Impact of times 86. Encourage widespread software development, standardized instruction sets, helps personal computers become mainstream. Example, a program written for an older x86 processor could still run on newer Intel CPUs with little or no modification. This decision helped x86 dominate desktops and laptops for decades. Part 2.3: The evolution of CPU processing power. As CPUs became more powerful, operating system evolved. Early computers can only one program at a time. Modern operating systems allow multitasking, memory management, process scheduling, CPU and OS relationship. The CPU executes instructions, but the operating system decides which program runs, when it runs, how much CPU time it gets. Example, when you open a browser, play music, and run a document editor at the same time, the OS manages CPU time for all applications. This evolution allowed computers to become more efficient and user-friendly. Part 2.4: The evolution of CPU processing power. The instructions of 32-bit processors was a major breakthrough. 32-bit processing allowed access to more memory, improved performance and precision. Pipelining. Pipelining allows multiple instructions to be processed at the same time, similar to an assembly line. Cache memory. Cache is a small, fast memory located near the CPU. It stores it stores frequently used data so the CPU doesn't have to fetch it from RAM every time. Example, without cache, the CPU would wait longer for data, which cache programs load faster and run more smoothly. Part number 3: Overview of GPU. Now, let us move on to the Graphics Processing Unit or GPU. Unlike the CPU, which focuses on general purpose tasks, the GPU is designed for parallel processing. Main function. Originally, GPUs were used for rendering graphics and images. Today, they are also used in artificial intelligence, machine learning, scientific simulation, CPU versus GPU, CPU is a few powerful cores, while the GPU thousands of smaller cores. For example, when rendering a video or training an AI model, GPUs can process thousands of calculations simultaneously, making them much faster than CPUs for this task. Part number 4. SAP1 operations. The simple as possible the simple as possible one, or the SAP1 computer, is a basic educational model used to understand CPU fundamentals. Main components: program counter, memory, instruction register, ALU, control unit, operations. SAP1 operates using load, add, store, halt. Each instruction is executed step by step using the fetch code, decode, execute cycle. The purpose: SAP1 helps students visualize how real CPUs work internally. Part number 5. SAP1 programming. Programming SAP1 is done using simple assembly language. Example program: a basic SAP1 program might load a value into a register, add another value, store the result in memory. Each instruction corresponds to a machine code stored in memory. Why SAP1 matters? SAP1 teaches how instructions are encoded, how memory addresses work, how control signals drive execution. These concepts are essential before studying modern processors. Conclusion. In conclusion, we explored how the CPU works, the evolution of CPU processing power from basic mechanics to modern architectures, the role of GPUs in parallel processing. SAP1 operates in programming. This topic shows how computing evolved from simple instruction execution to complex, high-performance systems. Understanding these fundamentals prepare us for deeper learning in computer engineering, system design, and modern computing technologies. And that would be all. Thank you for watching, and I hope this discussion helped you better understand how processor works from the simplest models to today's advanced system. Thank you and bye! Number 247348, let's explore what this case is all about. The key facts, legal issues involved, the Supreme Court's ruling, and my personal learnings from this case. Number 1 question: what is the case is all about? This case involves the conviction of a man, Christian Cadahas E. Cabias, for the crime of child pornography under Philippine law. The Supreme Court had to decide whether the evidence against him was valid and whether his actions constitute a violation of the anti-child pornography law in relation to the Cybercrime Prevention Act. Number 2, facts of the case. Here are the key facts. The petitioner, Christian Cadahas, was 24 years old when he met a 14-year-old girl whom the court refers to as Triple A at the canteen where he worked. They communicated through Facebook Messenger and began a relationship. Despite the girl being a minor, the minor's mother discovered messages where Kadahas allegedly include AAA to send sexually explicit photos of her private parts via Messenger. Based on this, the authorities filed charges. He was acquitted on one charge but was ultimately found guilty of child pornography for inducing the minor to send those images. He was sentenced to imprisonment and a fine. The Court of Appeals affirmed the conviction, leading to a petition for review before the Supreme Court. Number 3. What are the issues in the case? The main legal issues presented in this case were whether the evidence, specifically the Facebook Messenger conversation, was lawfully admitted and did not violate the petitioner constitutional right to privacy. Whether the petitioner's actions constituted child pornography under the Cybercrime Prevention Act RA 10175 in relation to the Anti-Child Pornography Act, which is the RA 9775. There was also debate over better consent, including the minor's seeming cooperation. Mothers in cases involving minors and sexually explicit conduct. Number 4. What is the ruling of the Supreme Court? The Supreme Court upheld the conviction of Christian Cadahas for child pornography. The court found that the record clearly showed beyond reasonable doubt that he induced the 14-year-old minor to send him explicit photos through messenger messages. The court emphasized that because AAA was a minor, she could not give rational consent to engage in sexually explicit activities, especially when influenced or induced by an adult. Therefore, Kadaha's actions fell within the legal definition of child pornography and were punished under the Anti-Child Pornography Law and Cybercrime Prevention Act. There and the last number, my takeaways or learnings from the case. Here are the key lessons I learned from these cases. The law protects minor rigorously. Even if a minor appears to consent, the law recognizes that children cannot give valid consent in matters involving sexual content. This is especially true where there may be persuasion or influence from adults. Number 2, digital evidence matters. Electronic communications like chat conversations can be powerful evidence in court, provided they are properly obtained and admitted without violating constitutional rights. Number 3, the justice system. Prioritize child welfare. The Supreme Court's ruling underscores the principle that our society places a high priority on protecting the welfare of children. Courts are unwilling to allow justification like sweetheart defense to undermine that protection. This case reminded me that laws evolve with technology and safeguards must adapt to ensure justice in the digital age. Our conclusion is overall, Cadahas versus People is a landmark case that shows how Philippine courts interpret child protections laws in the context of online communication and social media. It highlights the importance of ethical conduct, especially when the interacting with minors online. And that will be all. Thank you for watching. Please like, subscribe, and comment below what case you want me to discuss next. Bye!